As I said, you guys got your tests back, and the scores on this one were lower than usual. This is one of the tougher tests, so don't get discouraged. Make sure you do corrections on that and get it back to me. To start off Unit 5 today, we're going to look at ratios. And a ratio is one of the more powerful concepts in math. And all a ratio is a comparison between two numbers. For example, let's see, we're missing what? 1, 2, 3 students today. So we'd have the students that are missing to students that are here. We have 9 here, no, 8 here today. So that'd be a 3 to 8 ratio. We can write it like that as a fraction, 3 over 8. We can write it with a colon like this, 3 to 8. Or we can even write it with the word 2, 3 to 8, like that. All of those represent that comparison of students who are missing to the students who are here. Now, there are two types of ratios. The ratio I just put up here compares one part of a group to another part of a group, of the same group. And usually it's what we call complements, where the two things make up the whole group. You know, 3 that aren't here to 8 that are here. There's no way that somebody can be not in either one of those groups. Everybody has to be in one of those groups. The other way of doing it is comparing a part to the whole. So 3 to 8 would be 3 that are gone out of what would be the whole amount. Well, 3 plus 8 would be 11. So I can express that as a 3 out of 11 ratio. 3 that are missing out of 11 total students in the class. So as a fraction or with the colon, it gets expressed the same way. If I put that in words, it would be 3 out of 11 instead of 3 to 11. I'm not comparing two parts within the same group anymore. I'm comparing a piece of a group to the whole group. I can compare length to width ratios or width to length ratios on the table here. These tables are, what, 18 inches wide? And I know they're 6 feet, so 72 inches long. When I express my ratios, I usually express them as fractions like this, because there are a lot of things I can do with fractions that I can also do with ratios. For example, in fractions, I'd be able to divide out the inches, and I can reduce them. Both 18 and 72 can be divided by, what's that? 2, okay. So that's 9 over 36. They can still both be divided by 3. So that's 3 over 12, and they can still both be divided by 3. That's 1 and 4. You will notice that the units divided out here. So what is the units of this ratio? 1 what to 4 what? Well, it doesn't matter as long as they're the same unit. This could be 1 inch of width for every 4 inches of length, or it could be 1 centimeter of width for every 4 centimeters of length, or 1 foot of width for every 4 feet of length. Doesn't matter what units they are as long as they're the same. For every 1 unit of width, there are 4 units of length. You'll also notice in all of the ratios I've created so far, both we're comparing things that are similar. The same. These are students to students. Same here. Students to total students. Inches to inches. And that is one of the characteristics of a ratio, is it must compare two numbers or two things with the same label. If I had 2 feet to 18 inches, that is not a ratio. Now, fortunately, I can change this. I can rename it. 2 feet can become 24 inches. So now I have 24 inches to 18 inches, and that is a ratio because there are two things that have the same label or same name. So I can divide out the inches. Both of these can be reduced by 6 to give me 4 over 3. Now I said there are a lot of things that we can do with ratios that we can do with fractions. We can reduce them, we can divide out common units. One thing that we do not do with a ratio is we do not turn it into a mixed number. Because a ratio is a comparison between two numbers, 4 to 3. Not a mixed number. That whole number in front wouldn't make much sense for a ratio. So all of our ratios compare things that have the same label. Well, what if we compare two things that don't have the same label? Let's say we send Stone on a road trip here. And on his road trip, he drives 365 miles. And 7, it's not far enough. So, miles and hours are obviously different units, and there is no way to turn miles into hours or hours into miles. So this is not a ratio. This is what we call a rate. So the first big difference between a rate and a ratio is a rate compares things that have different units. Different labels, if you want. The second big difference between a rate and a ratio is a ratio is often left like this, as 4 to 3 or 1 to 4 or whatever. A rate is almost always expressed in what we call a unit rate. A unit rate means the denominator is 1. Or the second number is 1, if you want to think of it that way. So to do that, to turn this into a unit rate, I would divide by the numerical value of the denominator. It's 7 hours, so I'm going to divide by 7. So just like I would reduce a fraction, I'm going to divide both numbers by the same thing. 7 hours divided by 7 is 1 hour. 365 miles divided by 7 is 52.142857143, approximately, miles. And once it's divided into a unit rate like that, we'll round that off to 52.14. We often don't express it as this, like our ratios, as two numbers being compared anymore. We take that appearance of the fraction and we hide it in the units. So it might be 52.14 miles per hour like that. In fact, sometimes we even hide the appearance of the fraction altogether and write it as 52.14 mph. But when we see that, we need to know that this means the same as this, and of course that's the same as this. For example, let's say we have on this road trip that Stone gets 24 mpg. What does that stand for? Miles per gallon. 24 miles. And we need to think of it like this. 24 miles per 1 gallon. It is a unit rate. The denominator is 1, even though we don't write it there. This is the form we're going to need it in to do calculations with it later. So let's do some examples of rates. Rates really all around us. We saw here miles per hour, miles per gallon. Let's say you managed to drive 480 miles on 16 gallons of gas. Well, the units tell us where the numbers have to go. If we're looking for miles per gallon, which one has to go on top? The miles. 480 miles over 16 gallons. And we just divide it out. Divide by 16. What's 480 divided by 16? That is 30 miles per gallon. Another rate that most of you are probably familiar with. Let's say you earn $560 in a 40-hour week. What is your rate of pay? Well, you earned $560 in 40 hours. We can divide that out. What's 560 divided by 40? $14 per hour. Going the other way, if you earn, let's say you earn $11.50 an hour. When you look at that again, you need to be able to realize that that is $11.50 over 1 hour. Because again, this is the form you'll need it to calculate with. What are some other rates you can think about? Or think of? We talked about a few of them when we were dealing with measurement conversions. You might have a pump that can pump, let's say it can pump 300 gallons in 15 hours. That's 300 gallons, 15 hours, which is, again, you divide it out, 20 gallons per hour. That's a really slow pump. Should have been 20 gallons per minute. Yeah. Okay, let's look at ratios. Well, like a fuel pump on your car only pumps about that much.
Yeah. Not going to pump out your basement with that one.
What's that?
You're not going to pump out your basement with that one.
No. Let's do some ratios. Let's have some fun because I'm going to draw pictures. This is where you guys get to use your imagination because, well, I'm going to draw pictures. Any guesses? Wow, I didn't think I sucked that bad. Gear ratios.
Oh yeah, those are gears.
No imagination these days. So, I know, my artwork sucks. What's that? The bacteria, that was a pretty good guess. You're right. Not sure where you get the people. A gear ratio is the number of teeth in a driven gear compared to the number of teeth in the driving gear. Well, how do you know which one's driven and which one's driving? Well, we need more information than what I have here. So I'm going to do more artwork. Pretend that looks like a little electric motor. Now, if I separate these two gears, which one's going to stop turning? The small one, how many teeth does it have? 8, right? That is the driven gear. It is being forced to turn. It is being driven by the other gear. If I separate them, that's the one that stops. The one that is driving it or forcing it to turn is the big one, which has 12 teeth in it. So an 8 to 12 or a 2 to 3 gear ratio. That gear ratio describes a lot of things. That ratio, again, is teeth to teeth. It's diameter to diameter. Because if those gears are meshing together, the spacing between the teeth has to be the same. So that means the ratio between the diameters is equal to the ratio between their teeth, number of teeth. Also, it's the inverse ratio of their speeds. The ratio of their speeds will be 2 to 3, but the little one will be going faster than the big one in RPMs. Yes, exactly. So let's look at pulley ratios. Pulleys have no teeth. So we can't count teeth, so we measure their diameter. We could have measured diameter with gears as well, because like I said, the teeth are equally spaced. Again, it is driven over driving. So I need some more information. Again, pretend that looks like a motor. If I cut the belt, which one stops turning? The big ones. Was that going top or bottom? Top. So 15 inches goes on top. 6 inches, the driving pulley, goes on bottom. The inches divide out. 15 and 6 both divide by 3. Give me a 5-to-2 pulley ratio. Not only, by the way, is that the ratio of the size of the pulley and the ratio of the speeds, it's also your torque conversion as well. Well, since we're having so much fun drawing pictures, any guesses yet? Hey, good guess. Yep. Either my art's getting better or your guesses are getting better. One of the two. I'm voting on your guesses because my art probably isn't improving. You know. Compression ratio, exactly. Come on. A compression ratio is a volume to volume ratio. It is the expanded volume which is at your bottom dead center, compared to your compressed volume, which is your top dead center. So let's say that this is 520 cubic centimeters here. And this one over here, after it is compressed, is, oh, what do I want to get that down to? Let's go 80 cubic centimeters. So the expanded is the 520. Compressed is the 80. The cubic centimeters will cancel out. Both of these can be divided by 40, which gives me, what, 13-to-2? Now, some ratios, like our rates, are expressed as unit ratios. Compression ratio is one of them. You'd never say it's a 13-to-2 compression ratio. What would you say? You divide it out, 6.5-to-1 compression ratio. If you left it as 13-to-2, though, that would be okay on a quiz or a test. Talk about a roof slope. Does anybody know the definition of a roof slope? Fast you hit the floor. Definition of a roof slope. Actually, definition of slope period is rise over run. So let's say this has a 24-foot span, and it is 6 feet tall here. As I go up the slope from here up to here, how far did I rise? 6 feet. How far did it run? 12 feet, half the span. So this slope would be 612. Now, slopes are always expressed out of 12. People think that it's because it's 12, but what it is actually is a unit ratio. They divide this out to get 0.5 to 1, but then they convert it into inches. That's 0.5 feet to every 1 foot, but then they convert it into inches. So 0.5 times 12 is 6. 1 times 12 is 12. That's 6 inches for every 12 inches, or 0.5 feet for every 1 foot. I'm guessing you've heard the word pitch. Anybody know the difference between slope and pitch? Most of the time, if you hear the word pitch, they mean slope. Someone says a 412 pitch or a 612 pitch, it's the slope. What a pitch really is height over span. Kind of an outdated term. So the pitch of this would actually be 6 feet over the whole 24 feet, or a 1/4 pitch. The difference between them comes from difference in building styles. Years ago, before we had these prefabricated trusses, if you were building a house, you have your walls here, right? You're going to set a ridge beam up here, and you're going to cut rafters, right? Well, the pitch was used to figure out how high that ridge beam had to go. This is a 1/4 pitch. Let's say this is a 30-foot span. 30 times 1/4 is 7.5. So that ridge beam had to be 7.5 feet, or 7.5 feet above the wall. Top of it. Assuming you're going to notch the truss and or the rafter on both top and bottom. You're going to bird's mouth at both spots. Pit or slope comes into play with the prefabricated trusses. It literally is just saying rise over run. For every foot of run of that truss, it rises 6 inches, or whatever the slope is. Other ratios that are important outside of mechanics and construction. Yeah, we don't need to get too deep into it. Let's do, here's one you'll run into. A debt earnings ratio. Or sometimes called a debt to income ratio. If you go borrow money, this is going to be one of the key things. Credit scores are important, but they're not as important as they used to be. People think if you have a poor credit score, you can't get a loan, and that's not true. If you have a poor credit score, you're going to pay higher interest. The lower your credit score, the cheaper interest you're going to get. The higher your credit score, the cheaper interest you're going to get. But whether you get the loan or not is usually dealing with a debt to earnings or a debt to income ratio. And it is gross earnings or gross income that they're looking at. So let's say you have a job working 40 hours a week at, let's go $15 an hour. So for a month, 40 hours times 4 weeks times $15 an hour is going to give you how much? What, $2,400? You guys will be able to do better than that, by the way. Yeah. So anyway, well, first of all, as a welder, if you're only working 40 hours a week, it's because you don't want to more. You don't want to work anymore. Yeah. You guys should start out at 16 or 17 on a probationary and probably be up to 19 or 20 within the first 6 months. So $2,400 an hour is your income. Okay, so now let's say you have other debts. Let's say you have a credit card payment of $200 a month. We'll keep it on the low end. So you have a car payment You guys strike me as truck people, so we're gonna put that at $400 a month. So right now you have, what's that?
I wish I only paid $20 a month on truck payment.
I was being conservative. I know people are paying $700 a month on their truck payment. That's on an 8-year loan. I'll show you. I showed you guys what it cost you to buy a $50,000 truck, didn't I? Show you what the payment is, and then what the total payment is over 8 years if it's financed over 8 years. Yeah, it's nuts. So anyway, right now your debt to income ratio is 600 to 2400, which is a 1 to 4. Their maximum ratio is usually a 1 to 3. So if you go over a 1 to 3 ratio, you can't borrow any more money. Now, one of the reasons for the big mortgage crisis, the loan crisis about 8-9 years ago, was there were government organizations that were pushing low-income loans for housing, and they were pushing banks to make, instead of going to a 1 to 3, they were pushing, oh, let's do a 2 to 5. Well, this is 33%, this is 40%. So bumping up their debt, that 6.5%, 7%, made it just that much harder for them to, if something went wrong, they didn't have any cushion to make their debt payments. So anyway, right now, what would this top number be if this were a 1 to 3 ratio? What would this top number have to be? 800, right, would make that a 1 to 3. Which means you have how much room, how much purchasing power do you have? You're at 600, you can go up to 800. You got $200 a month that you can add to your payment. So if you want to buy a house, you got to keep it under $200 a month. Yeah. Yeah, you want a house that you can't hook on and take with you. I've seen a couple. Not $200 a month, but I know I helped a friend get set up in one here just about 2 years ago. The actual payment on the loan is like $240 a month. And with insurance and taxes escrowed, I think it's $480 is the total payment. Okay, so homework for you, page 282, exercise 7.1, 1 through 65, the odds.